Hello everyone, hope everybody is doing well. This is the fifth lecture on IoT, and we stopped at the network layer last time. Before talking about the network layer, let's refresh our memory of what we have learned thus far, and then we will go on to the subject matter. So initially we talked about IoT. We took an introduction to IoT, and we talked about how to define IoT, and we then looked at examples of IoT and how these IoT devices work with networking, and how these IoT devices communicate between each other to deliver the full IoT experience. We look at several examples from temperature control to fire extinguishing. Then we looked at weather related weather monitoring IoT apps used in different industries to different things. Then we mix and match, and we looked at how different industries use same kind of IoTs for different purposes, or could be the same purpose as well. Then we talked about the architecture, and in the architecture itself we talked about the four main parts which builds IoT system: devices and sensors at the perception layer, the network layer, cloud platform layer, and application layer. So in this IoT study, we are mainly concerned about the first two, right? And our end goal is to build a IoT device or an embedded IoT device, rather than concentrating on building an entire IoT system. So when building IoT device, then we should concentrate on the perception layer and the network layer, especially the perception layer. And in the perception layer, we talked about the components that are there, so we should know how to network them and make them communicate. So introduction to basic IoT components. Here in these components, the perception layer we talked about would have sensors, actuators, and embedded systems. Then they will be networked between each other and will be talking to each other, right? In this, the network layer, we talked about special networks that are there for IoT systems as well. Then again, we concentrate here in this lesson mostly on the networking and the hardware which is used to build the embedded IoT system, right? Then after that, after taking all the introductions, we took introduction to sensors. We talked about what are the so first we took look. Then now we know to build a IoT device. To build a embedded IoT device, the main or the first thing we should get to know is the hardware components of it, or the perception layer. In the perception layer, we talked about sensors. We talked about examples of different sensors, how to choose them, and what are the things that we should check before choosing them, and what kind of categories are there when coming into sensors, right? We talked about temperature, humidity, pressure, motion, proximity, light, gas, sound, accelerometers, magnetometers. We talked about how these are being applied against the examples we talked about earlier, right? Gyroscopes, infrared sensors, image sensors, and moisture sensors. These are 14 sensor types, but again they are not limited to only 14. There are more, and we also talked about how these sensors are used in our examples of embedded or IoT devices, right? So after that we went on to talk about actuators, right? actuators, and we defined actuators as well. We talked about motors, solenoid valves, arrays, and how they work and how to choose them, their properties, and having the correct product. We then talked about servo motors. Then we talked about LEDs, speakers, and displays. These are more outputs towards human understanding, interaction. Then we talked about pumps, actuators for locks, actuators for curtains, linear and circular motion. Here we highlighted. So again, when coming into actuators, we dove in deeply. We talked about those things that are there on the market, and according to the need, we should be able to understand what kind of actuator, what is the power of the actuator which is needed, what are the properties that are needed, power supply, and so on and so forth. We talked about all of these things. The next thing that comes to our mind is that if there are sensors, and these sensors collect data from the environment, and when processing of this data then by processing this data we can get information, and we can give commands to these actuators to function. This is what we talked about when defining these things, right? IoT sensors are physical devices that collect data from the environment and transmit into other devices and systems over the network. So that means these are going to be networked. IoT actuators are devices or components of IoT system that take action based on the data collected by the IoT sensors. So that means these data, they collect data and they send data, and when those data is processed and received by the actuators, they take actions. So that means there is a network that is going on. That bit is obvious. So when talking about Internet of Things, when talking about the Internet itself, the network layer or the networks are very important to talk about. Here we talk about network layer in a sense, right? Not only the network layer over here, we are not going to concentrate much on the network layer of the entire architecture of IoT. We are going to concentrate on the network devices when building an IoT component. So we are going to actually, when we talk about the network layer, right, we are going to, when we talk about networking in IoT embedded devices, we are mostly going to talk about this, right? For now, we talked about things in the perception layer. Now we are going to take a general understanding of the network layer. Network layer, of course, first and foremost, when communicating through the internet, right? I think you are familiar with the seven layers that are there to facilitate transfer of data. Okay, so physical layer transmit raw bit streams over a physical medium. Data link layer defines the format of the data on the network, right? Network layer decides which physical path the data will take, transmits data using transmission protocols including TCP and UDP. Session layer maintains connections and is responsible for controlling ports and sessions. Perception layer ensures data in a usable format and is where data encryption occurs. Application layer, human compute interaction layer, where applications can access the network service. So these layers which are there in networking are also there in IoT networking as well, right? I added this part here recently just to say that there is no difference between IoT and, let's say, a web application or an app in your phone on communicating through the internet. The method of sending messages and so on and so forth follows the same rules, the same steps of internet networking. So then what's so special about IoT that we are going to talk about network layer in a extra way? What is the extra bit of a network which is there on IoT? So in that we will find that on the physical layer, right? This layer deals with the physical aspect of communication, such as hardware transmission medium and protocols used to communication between the devices. It includes technologies such as Wi-Fi, Bluetooth. These two we know. Then we have a word called Zigbee and LoRaWAN, right? So these two, Zigbee, LoRaWAN, or we talked about other communication methods also here, right? Like Z-Wave, NB-IoT, Sigfox. So these things are also communication protocols. Dedicated, those names and those protocols are dedicated to IoT systems, right? We will talk about why they are made and why they are there in the first place, what are the properties they have, why are they used over having Wi-Fi, right? Because if you are thinking about a smart home, right, one Wi-Fi router is more than enough to help carry out all the communications between IoT devices inside a home. But if you take a factory, that's a different story. So we will talk about why these dedicated protocols are there for IoT devices. Then we have the data link layer. This layer is responsible for establishing, maintaining communication between the devices, ensuring the reliability transmission of data. It includes protocols such as Ethernet, Wi-Fi and Bluetooth. These things, okay, so now if you take these protocols, the data link layer of it, right, our main concern goes to the physical layer, right? So if you take the physical layer of it, right, there will be IoT devices there connecting between each other, talking to each other, before sometimes taking our data to the internet itself, right? So data link layer, so by Ethernet, Wi-Fi and Bluetooth protocols we know. Network layer, this layer is responsible for routing of data between the devices, ensuring that data is transmitted efficiently across the network. It includes protocols such as IPv6, there's IPv4, now it's we have IPv6, 6LoWAN and RPL. So these are also protocols or addressing protocols. Things that you can understand is that normal internet usage use Wi-Fi or cellular network to communicate. Bluetooth has its own protocol to communicate. Similar to that, we have some words running around like 6LoWAN, right, Zigbee and Z-Wave, things like that running around inside IoT network layers. So those are the points that we have to concentrate on. Transport layer. This layer ensures that the reliable and efficient transmission of data between devices, handling issues such as packet loss, congestion control, and retransmission of lost packets. It includes protocols such as TCP and UDP, right? If you have learned network, these definition, and if you have learned networking, not IoT networking but basic networking, these same principles can be seen. Then the application layer deals with the application level protocols using the transmission data between the devices. It includes protocols such as HTTP, MQTT, and CoAP. So in this in network layer, when the device is talking to the internet, all these transmission protocols should be there to send a message or send a data packet to another device which is far away through the internet. We talked about examples. When we talk about examples, let's go to the weather example again. So this data would be sometimes collected, let's say in Colombo, but we need to give that data to Kandy. So that means that data there cannot be a dedicated wire or a wireless system just for that. So that means this data should be traveling through the internet itself. If it is traveling through the internet itself, the networking should follow these protocols, thus have these layers between them. So then again, networking itself, right, is a different subject, and I told that we are going to talk about networking between IoT devices, where different protocols rather than protocols used in Wi-Fi or Bluetooth comes into play. There are reasons for this, right? There are reasons for this, and we need to deep dive into understand what is Zigbee or what is Z-Wave or what is 6LoWAN and those things to understand them. For now, as an introduction, the main thing that is needed to I think the main thing that is needed to be understand and here is that each if you have a IoT system and that IoT device, you have one IoT device here, you have another IoT device here, and you have another IoT device right here, another IoT device right here. So the communication between these IoT devices, right? The communication between these IoT devices should not always, but sometimes is not always with protocols that we find with Wi-Fi, right? Because when it is only connected to the internet, to a router or something, and then it goes to the cloud, and then it goes far away for another IoT device, right? it goes under the normal protocols. It goes under the normal protocols of transferring packets through the internet, data packets through the internet. But that amount of energy, that amount of energy, or that amount of protocol or resources is not needed when transferring data inside a small IoT intranet. So that is why that is couple of IoT devices, even thousands of IoT devices, just exchanging data between each other does not require, if it doesn't require to connect with the internet itself. That means we can use other protocols which are more efficient, which is more friendlier with IoT devices, right? So for now, for basic understanding, the network layer has the 7 this is the standard networking protocol. These are the layers that are there. IoT devices like, let's say, Alexa, your phone, your smartwatch, your self-driven vehicle, and your Roomba would have these protocols inside them to communicate through the internet. So it will be a proper internet communication, right? But there are other protocols as well. Right now I'm not going to one by one, I'm not going to explain everything, because in a future lesson we are going to look at IoT networking solutions, why we use those solutions, and so on and so forth in a future lesson, right? So what I'm going to do here is similar to actuators and sensors. We looked at common categories. We are going to look at network layer. What are the options are there? First and foremost is the Wi-Fi. There are Wi-Fi small chips or small cards or small boards available that, when connected to the embedded system, and when the actuators or the actuators and the sensors can transfer data through Wi-Fi. Wi-Fi is a popular wireless network technology that is commonly used in home, office, and public spaces. It is used in many IoT devices such as smart speakers, security cameras, and home automation system. One of the properties that we can use is, compared to IoT communication devices, Wi-Fi has a greater capacity to transfer data. In that perspective, when you have security cameras, and if you need a HD HD video feed from that security camera, it is better to have a Wi-Fi IoT device rather than using other protocols. So again, depending this again, as we talked about in sensors and actuators, there are parameters, there are limitations for each and every kind of network device which is here, or network solution which is here. So we should know, for example, Wi-Fi and Bluetooth, here they consume more electricity than other methods. If you take cellular connectivity, right, this is something that you know. If you take cellular connectivity over Wi-Fi, cellular connectivity consumes more energy. It will drain your battery over using Wi-Fi. So now we know that, okay, if we are going to use an energy efficient solution between cellular connectivity and connecting to the internet and Wi-Fi, we can use Wi-Fi because it's much more energy efficient. So things like that. Bluetooth is a wireless technology that is used for short range communication between devices. It is commonly used in wearable devices such as fitness trackers and smart watches. Bluetooth is something that is being used less and less these days, but then again still you have the Bluetooth option in your phone. You can transfer your data. You can see that again in wearables, fitness trackers and smart watches, Bluetooth is there to transfer data to your smartphone or to your app, smart app. It will get data from your watch or Fitbit through Bluetooth. Of course, then again your wireless speakers or wireless headset, so in those devices, right, part of IoT devices, right, will get data through Bluetooth. So then Bluetooth becomes a very powerful communication medium. Again, there is a part that is needed to be highlighted. See, there's a property that there it's a short range communication device or a short range communication method. So that is something that you have to keep in mind. Comparative to Wi-Fi and Bluetooth, depending on the range, what would you use? We will use, if we need more range, it would be Wi-Fi as option. Then we come to Zigbee. Zigbee is a low, these circuits what you see here is are circuits that allows the embedded system to use these communication protocols. They are with antennas. You can see the antenna, Wi-Fi antenna over here, Bluetooth antenna over here. You can see the Zigbee antenna over here, right? And these these communication these units, these devices, when connected to the whole embedded IoT device, we can use the technology that they facilitate, right? If we are to communicate, let's say we want to communicate between a gas sensor and actuator, which is let's say a pump, right? Both of them can be connected through Wi-Fi by connecting these Wi-Fi modules to that, right? Again, don't worry, we are just going through the components of it. We still haven't started to put them together to create a IoT device. So first we will just go through what is there on the market, or what is there, what are the technologies there, so we can get familiar with what is this. So in Zigbee, Zigbee is a low powered wireless technology that is designed for IoT devices. It is commonly used in home automation and industrial applications. Zigbee is a low power wireless technology that is designed for IoT devices. So Zigbee here is dedicated to IoT devices. This is something very important. And what is the property that Zigbee gives here? It's a low power device. So communications can be carried out with low power. Why it is important? Because sometimes when you have let's say IoT devices which are connected, which are off the grid and working through small batteries, right? Small batteries and things like that. Let's go for example. Right here we have the weather monitoring device. Let's say the weather monitoring device is top of a mountain where there is no electricity and there's only a solar panel there. The solar panel can only charge it throughout the day, and at night there's a small battery to give out information. Now can something which is consuming a lot of electricity, if for communication, can be used in that particular point? We cannot. So then Zigbee comes into play. If we have if we have a thermostat which is not connected to the grid, but it is but we bought from let's say online, put some batteries in, and we paste it on the wall. That means for communication, right, to get that communication and things, we need a low power wireless option like Zigbee. If you take the lights, right, there can be one or two lights, but inside a building there will be hundreds and thousands of lights. In a city, in the road, there will be humongous amounts of lights available, 1,000 to maybe 1 million. But communicating with all these lights, do we need to maintain a full Wi-Fi grid? It's not possible. Cellular, a little bit expensive. Maybe the protocols that are there on Zigbee and the low energy that it consumes will be more than enough to communicate. So we will look into that. We will, as I told you, in going into the future, we will look into what are the networking protocols or networking options that are there for IoT, especially for IoT, right? Wi-Fi and Bluetooth and those things, I think you may have learned in other lessons as well. So we will a little bit concentrate on protocols that are dedicated to IoT itself. And I'm assuming that you are familiar with the layers of when building a network. You are familiar with these things as well, so we don't need to go through them step by step, because here in itself this is a network lesson, little bit out of the scope of IoT, right? So then again, Z-Wave is a wireless technology that is used for home automation and security systems. It operates on a different frequency than Wi-Fi and Bluetooth, which reduces interference. Now you can see in that definition we use something called Z-Wave, and why we use it? It works in a different frequency, so Wi-Fi and Bluetooth cannot, the interference of Wi-Fi and Bluetooth is not there. If you have a home with a wireless speaker set, if you have a home with Fitbits, smartwatches, Bluetooth keyboards, Bluetooth mouse, Bluetooth things like that, if you have a Wi-Fi system that connects to your smart TV, to your smart fridge, to your laptop, to your tablet PC, to your 4 or 5 phones in the house, things like that, that frequency level is saturated. It is a lot of data is being passed around and it is saturated. Therefore, communicating in a different frequency itself, especially IoT devices, small IoT devices such as smoke detectors or temperature control units, which need to communicate between each other, or small like the lighting system and so on, which is needed to be communicating either all the time or at some times clearly, they can use options like Z-Wave. Then we have LoRaWAN. LoRaWAN is a long range, low power wireless technology that is used in IoT devices. It is commonly used in smart cities, agriculture and environmental monitoring. Okay, now you know, we talked about the example before, right? Your mind should quickly go to this example, right? And we talked about long distance communication with IoT devices. And what is the option we have? LoRaWAN we have, because long range, low power. Long range, low power. So rather than using Zigbee, the best option for that example is LoRaWAN. because it has the property of long range and usage of power is very low. So this is why it is needed for IoT itself, right? IoT networking is a subject of its own, right? Similar to the sensors, we have to see what kind of a communication that is needed to be carried out, and we have to select the correct network option or the network protocol to carry this out. NB-IoT is a low power cellular network technology that is designed for IoT devices. It is used for applications such as smart meters and remote monitoring. Smart meters, yes. When saying about smart meters, think about an option. If we are to build a smart electricity meter and a smart water meter, something that is not there in Sri Lanka, that is something that we can build. If we are to build such a thing, there's no need for everybody to come and somebody to come and mark the water meter by itself. Automatically the data will be transferred into the cloud, right? The calculations will be done and you will receive an email or a message on your phone. This month's bill is this much. NB-IoT allows that because it's a low power cellular network technology. That means we have cellular connectivity around Sri Lanka. Most of the cellular connectivity is comparatively good in respect to other countries because there's a very small land mass to cover. So we can then, when we talk about smart meters, we can use this technology so that we can take advantage of the cellular coverage we have around the country to make this smart IoT device work, right? Again, you can see that different networking protocols have different ranges, had different properties. So we should know what is our application, right? What is the problem, what is the application, and what is the best network to use to facilitate that application. Quickly, when we were thinking about smart meters, that option came to my mind. I think in Sri Lanka they are trying to, or one day they will, or sometimes even you will be the person who will be designing it, right? When designing it, either NB-IoT or there will be a much better option out there, right? So you will be the engineer who have to check and take the correct option. So you will build a IoT system for the electricity grid and also the water board to automate their billing system. That is a very good example for IoT application. Sigfox is a low powered wide area network technology. So LoRaWAN comes into mind. It is also long range, so that is wide area is long range, low powered, both properties are there. That is used in IoT devices. It is commonly used in asset tracking, smart cities and agriculture. So you can say when talking about asset tracking, it would be a large warehouse, smart cities a large area, agriculture again a very large area. When we have IoT devices, let's say moisture sensors are there too. We talked about moisture sensors and how we can use them, and now we know how to get data to a central location of the moisture sensor. We can use things like Sigfox or LoRaWAN, right, to transfer that data long range, and we don't need much electricity, right? A single battery IoT device is more than enough to monitor, because these wireless communication systems use very little energy, right? So these are few of the options which are there when designing a IoT device, right? Designing an IoT device means it should be able to connect to a network, and through that network to the internet itself. And when connecting to a network, and when devices, sensors or actuators or embedded processing systems talking to each other, it is important that there should be protocols, standardized protocols when talking to each other. Standardized network protocols should be there. Anybody who learned networking would understand that when machines are talking to each other, there should be a set of rules, set of protocols to ensure the compatibility between the devices. And for that we have these when coming into IoT, these options are there with unique properties to help IoT devices for their networking and communication. So now we come to IoT embedded systems. Here is the main part that we should learn when building a IoT embedded system. Till this point, we talked about the perception layer, we talked about sensors, right? We talked about actuators, right? How the sensors collect data, how the actuators work under commands, and then we talked about networking, right? Now we have to combine all these devices, right? We have to combine all these devices, the hardware, the software, the coding have to be done, and everything have to be done, and we have to make them into a bundle, make them into one collected device. So to do that, we can use IoT embedded systems, right? So I just had a note here. So we talked about devices, or the perception layer plus the network layer equals to embedded system. So yes, to build a IoT embedded system, this is our end goal, right? In this lesson, building a IoT device is our end solution. To build that, we have to have an embedded system, right? So let's talk about IoT embedded system. IoT embedded systems are small computing devices that are designed to be integrated into IoT systems. In the first sentence itself, we know that it is a small computing device, so it has computing power. They typically consist of a microcontroller or a microprocessor, memory, input-output interfaces. Input-output interfaces means there is networking, and communication interfaces such as Wi-Fi, Bluetooth and cellular network. So again, input-output interfaces plus other normal means of Wi-Fi, Bluetooth communication, cellular network communication. Again, input-output interfaces are the interfaces that we need to talk about when the microcontroller, the microprocessor, right, takes in and feeds out information from these sensors, actuators, right? That is the main part, right? And they have communication interfaces, Wi-Fi, Bluetooth and cellular networks. That means when the IoT system needed, when a IoT device needed to be connected into the internet, we can do so through the embedded system itself, right? That means in these computing devices, Wi-Fi chips, Bluetooth chips or Zigbee or whatever the solution, the communication solution is already embedded in the system itself or the motherboard itself. These embedded systems are used to collect data from sensors, process the data, and control actions of IoT actuators. This is the simplest definition that can be given what this has been done. Right now we are actually at the processing stage of these sensors. The data which we get from sensors, and we need to process that data, and we need to command the actuators on what is needed to be done, and that particular part is done in these embedded systems where there is processing and memory sufficient enough to do so. They can be programmed using various programming languages such as C, C++, Python or Java, and can run on various operating systems such as Linux, RTOS or Windows. Right? We will learn about how to code, how to connect, and these things in future lessons. This is just a introduction. So we know the languages that is needed to be used, and hopefully I think you have a fundamental understanding of C, C++ or Python, right? Even if you don't have an understanding of the language, I think you have a fundamental understanding of loops, commands, if, do, while, and those things, right? I think you have an understanding of those, but we will go through examples of coding and try to understand how it is been done in future lessons. IoT embedded systems can be used in a wide range of applications such as home automation, industrial control, environmental monitoring, healthcare, and smart cities. So basically, whenever IoT device is produced, there is processing power in the IoT device itself. We went through many examples. If you talk about the smart fridge or the robotic arm or self-driving cars or the Roomba vacuum itself, there is processing power. We talked about it. We know that it doesn't communicate all the sensing data into the internet to get the outcome. It processes inside the machine itself. So we know that there is some kind of processing power inside the device itself. So this is the embedded system is that. They are often low power and energy efficient and can operate on battery or other energy sources for extended periods of time. Again, this is something we talked about when talking about network devices as well. We talked about there are custom built network protocols just for IoT devices to preserve energy. This is mainly because some IoT devices needed to function with small amounts of energy, like smoke detectors and such, right, or wearable items for healthcare products, which needed to last a long time with a small amount of energy. And this is something that is expected from IoT device. Low consumption of energy is something that is expected in a IoT device or IoT system or a IoT solution. So though there is processing power, it is very energy efficient and can be operated on batteries, and that means in low power it can be operated. Some examples of popular IoT embedded systems include Arduino, Raspberry Pi. I think you have heard of these two, right? BeagleBone, ESP32 and STM32. These systems are widely used by hobbyists, students and professionals, so everybody, to prototype and deploy IoT systems. So that means we can use these boards, we can use the processing power of these boards to build IoT systems. In this lesson we will be focusing on Arduino mainly and Raspberry Pi. What my goal here in this lesson is to teach you whatever the system that you are going to use, right? How to understand in learning that particular system. Because if we are to learn each and individual sensor, each and individual system itself, it will take forever. So here we will go through in future lessons we will go through examples how to read through the data sheet, how to get the information which is needed, the code, and so on and so forth, right? How to code, how to take in sensor data, how to process them, and how to give a output. We will learn about these. Before everything else, we are just getting to know what are the network devices that are there, what are the actuators that are there, what are the sensors that are there, right? So examples of IoT embedded systems. Number one, Arduino. Arduino is an open source electronic platform that is used to create interactive projects and prototypes. It consists of a microcontroller, a development board, and software development environment. Arduino Uno, right? This is the main one that is normally being used for prototyping and to learn about IoT, right? So it has its own features, right? We will talk about them, right? But even Arduino today, there are products that are the processing power is powerful enough to build a full IoT system. So when talking about Arduino, the main thing that is the main board that we have to talk about is Arduino Uno. This is the most popular Arduino board and is used for a wide variety of projects. It has 14 digital input-output pins, 6 analog inputs, and a USB connection and a power jack. So those are the input devices. So you can see the pins over here, right? You can see this is the power port over here, the microcontroller over here, right? So this is the mostly used board, right, for prototyping or for mainly for understanding or building IoT projects, right? Before going further into what are the other Arduino boards available, let's visit their site and try to understand about this Arduino board. Here is the website for Arduino, right? Arduino.cc, and we are in the store section of it, as you can see from the top, right? From the address, and we are going to now look at what are the products that are being offered by Arduino, right? So again, this is similar to selecting your sensors, actuators, right, your network connectivity. When you are selecting your hardware device, the hardware device will come with set of parameters. There are physical parameters, the actual size of the Arduino board or the sensor, then the processing power of it, the capabilities, right? So we have like the first product here, Arduino Giga R1 Wi-Fi, right? As the name suggests, that means it would have Wi-Fi capabilities as well. So it is more, it provides more processing power if we are looking for a particular set of tasks to be done which would need a lot of processing power. Then we have the Arduino uh, Uno, which is their initial main product, Rev 3, then Arduino Uno, MSD version. You can see the chip changes, right, for a microcontroller, integrated circuit to a microcontroller. Then we have Leonardo, and we have other versions of it going down the list. So selecting what is needed from the properties, right? Like if you say Arduino Micro is a good example for selecting some embedded system with size constraints. For example, if you want to build a small IoT device, you can use Arduino Micro board to build it rather than using Uno, because it's a little bit bigger, right? So after that we can see the product itself, right? This is the board that you will normally see in Arduino, right? We will go through what are the features that are there, and but we will not look into it very deeply in this section of the lecture, right? We will try to understand what we are actually looking at right now, right? So let me put the other picture. This is the behind part of it, right? And this will be the product, right? You will have your pin connections, your processing, your USB B port connectivity to your laptop for programming, and your power supply, right? And of course you will have your spec sheet to show what are the parameters that it can achieve, right? And how it works on, what are the limitations, and so on and so forth. Then if you go a little bit down, you will see that you will find the schematics, board size, and so on and so forth, and you will find the data sheet, right? So in the data sheet, as we talked about, in every sensor, every hardware device, the data sheet contains all the information that we need about that particular hardware device, right? This is the input output diagram. We will see it in the we would see it in the data sheet as well. So one point to be taken, right? If you go a step down, you will see another diagram of how the circuits are working, and in this when building simple embedded IoT device, these we don't need to understand each and every logic gate and every part of the circuitry, the electronics of it. We don't need to go through them. We should, however, know about these pins and how to connect them, how to program them, and so on and so forth, right? Our main task would be connecting this Arduino board to a sensor, then to a actuator, and network them in a way that they would work, where the sensors would collect the data and maybe display, or will then, after collecting that data, a set of commands will be written, right? When the parameters are met, the commands will go to actuator, things like that, right? So let's quickly go to the data sheet. This is the data sheet for Arduino Uno R3, right? So we have the processor name, we have the memory, what kind of memory is available in that. As you can see these from the specs, that these are not very high power processing machines, but for simple projects Arduino Uno is more than capable of handling them. We have the peripherals, the processor, the memory, and the power. Then if you right, table of content, the board information about it, thermal limits, right? You can, these are parameters that you want to check whether if you are going to use it in different conditions, right? You can see the limitations of the board performance. And here, right, again we talked about so power jack over here, right? X1 is this one, right, on this board, which is recognizable. This is the power jack, where you will be connecting from the wall directly to the embedded device, right? And you will have USB B connector, where you will be connecting in your device directly to your PC, right, when you start coding. We will discuss about those particular parts in future when we are looking at examples of IoT projects, or how to build IoT, or learning how to build IoT embedded devices, right? Again, power distribution, and we have our connectivity pins, right? Over here we have a couple of LED lights, one to show that there's power to the device, right? Then XT LED and TX LED and RX LED. So transmitting or receiving data will be shown through those lights, right? Then you have a set of lights over here, sorry, you have a set of pins over here. So we are looking, if you look at the diagram, we are looking at these pins over here, right? As you can see, if you look closer into Arduino board, right, if you zoom in closer, you can see that every part we need to know is named, each pin is named. So it is easier for us to look at the schematics and then correctly connect. If you see on the top of the board, you can clearly see, you can see what pins are the ground, what pins give a 5 volts, what gives 3.3, the reset pin, and so on. We got the analog inputs, you can see it's clearly named as power. Then we have the analog inputs over here, right? We have the analog inputs over here. If you see, okay, we have the power section for it, 5 volts rail, ground, right? So if you want to have a device which is 5 volts, let's say a simple sensor which is needed to be powered, we can give through this, right? We have to first see the schematics of that particular IoT device and do the correct connection, or otherwise it would be a failure. Then we have the analog input, general purpose input output ports here, and we have the digital general input output ports in the other side, right here. If you take the diagram, right, digital from here onwards is digital pins, right? We have let's see what are the digital pins are. It's D0, D1, D2. Okay, then it starts from here, 0, 1, 2. From here you can see the schematics, D0, D1, D2, D3, and so on and so forth. So for digital outputs and inputs, general purpose pins, and you can see over here, right? Then again, moving up, we would have right, we have ISP connectivity, and we have another ground. We have SPI chip connectivity, the serial clock information, and those things which sometimes needed to be used, but not most of the times. It depends on the sensors. We will talk about how these ports are needed when we are looking at the projects. Again, I2C data links, analog data links, and there's input data links. If the sensor demands these criterias, only we need to use them, right? Mainly we need to concentrate on the power, the ground, right? When we are giving the power and the ground, then what are the requirements which we can then program these general purpose input output pins to send the data from the chip to the sensor, or taking data from the sensor and give out data to the actuator, right? So a data sheet, we talk about it from top to bottom. It will be like this. So each and every product would have its own data sheet for to receive to convey information to the engineer, which part is doing which particular job, or how can we use these pins, or what are these hardware devices which is there, right? For and how to use them, right? We need the particular information, and that particular information that we can take from the data sheet itself, right? So right now I'm going to limit the amount of information that I'm going to give. I'm just because when we start working on Arduino or Raspberry Pi, one of those, when we are trying to do the project, we will understand how to connect these, right? This is also article, connect these, and how to basically how to code the communication between these two devices, the sensor and a Arduino. So I'm going to use this example, right? I'm going to use this example just for now, how these how a simple connectivity happens between a sensor, in this case a camera sensor, and an Arduino embedded system, right? We can see the 3.3 volts, right? So the connectivity should be 3.3, right? In the data sheet of this, those information will be clearly stated, right? We can check, we can see where the wiring takes place to 3.3, and we could see the same is given to reset pin as well, right? Then we have one for the ground, and one for the power down, another, and we could see that there are two set of resistors that is being used when communicating the information. We have two analog inputs coming in, and three digital inputs which are being used. So the only thing is, now looking at this schematics, that it would not make any sense what is actually happening, right? Because you will see like, this pin is connected to this pin, this pin is connected to this pin, this pin is connected to this pin. So to make sense of it, we have to look at the particular set of coding that would take place. For that, we will look at a project. So this is one of those example projects, but going into the future, we will talk about a full project, how it would be done, right? This is just there for example for you to see that, okay, if you have a sensor like this, we have the sensor information, a data sheet, and from that sensor data sheet we can see which pin is to be connected to which, right? That information would be there, camera module to host, right? How these things will be connected and which pin is doing what, right? Then we can use this data along with the data sheet of this to make a reasonable connection between the device. I'm the main point I want to show you is the connectivity between the sensor and the embedded device. It would look like this, right? Let's try to okay, so it would basically look like this. Down here is a breadboard, right? We will learn about what's a breadboard. We will learn about how these wiring work, what are these pins, how to connect them, right? In a theoretical sense, we will learn about it, right? When you are doing a practical, then you will physically have to connect them and get to know what is what, right? For now, we will try to understand how to do it theoretically, right? So you can see the connectivity, the end product, right? At the end, we are trying to learn, right? We are trying to learn how to make a IoT device like this. A prototype of IoT device or a project of IoT device, let's say a camera, would be something like this. For those who are looking closer into the picture right here, you can see that this is not the Arduino Uno Rev 3. You can see that the chip is different. That means they are using a different chip. It would be SMD version of it, right? So it doesn't matter what is the sensor, what is the company which makes the sensor. It doesn't matter what is the embedded processor and the company that makes the embedded processor. We should be able to connect these devices correctly, plus we should be able to code the inputs and the outputs correctly. But at this particular juncture of the lecture, right, I don't want to complicate things much. I'm just trying to explain what is an embedded device, right, and to show how this embedded device how this embedded device works together with sensors and actuators. So we have another article that I selected just to show you what are the main connectivities that we need to rely on. We talked about analog inputs, we talked about digital inputs and outputs, right? So these digital inputs and outputs will be carrying out data in and out from the embedded system. When data is received, let's say from the camera or somewhere, where would it go? It will go to the microcontroller where the processing takes place, right? USB-B connectivity here, right, where we can connect directly to our PC, and from that we can feed in code, right, how and what is needed to be done which pins needed to be activated, what are the signals that should be sent, and so on and so forth, and how this microcontroller should process data which is receiving and the commands that are being sent. Again, DC barrel jack, the power. So the main things that we have to learn, we have to get to know here, right? You will see that there are ICSP pins available here and this corner, right? The regulators and other chips, capacitors are there. Are two capacitors here, you can also see. So these are, if you are going to dive deep into what is each board, right, you will see those all the features are there. But when we are only going to design a IoT device, our main purpose of utilization is of this embedded system is to use this as a platform to program our data, program the sensors and the actuators, take in the data, data input and output, whatever which is right. If the sensors detect something, take in that data, process that data, and send an output to the actuator itself, right? To do that, we need a platform. We cannot connect, because each sensor does not have the processing ability to handle all that. We need something that is needed to be connected to a PC and which has enough processing power to execute those codes we are putting in. The embedded system is that platform, right? That's the best way of defining it. The embedded system is that platform. So you can see again, DC in, USB, input output ports we have from both sides, and we have a microcontroller. So all embedded systems are basically built on such a architecture, right? I will put these links for you to follow, and maybe if you are interested in understanding what is what in a board, right? But then again, you can see the schematics of the circuit diagrams of it, and unless you are a student of electronic engineering or mechatronics, right, a deep dive into these parts will not be necessary for this lesson, right? These things is not needed. We just need the platform to use to communicate with sensors and actuators. Rather than that, right, beyond that, how to actually build such an embedded system is beyond IoT, and it will go to deep electronics and R&D section. So we don't need to move that far, right? So most of the time I would be trying to limit our lessons or the examples to the point where we can actually build such a device or to build such a project, right? We would have a sensor, we would have a embedded system. Additionally, maybe we would have actuators working, right? So our target is to go to building projects like this is by combining in the sensors and the embedded system, and using the embedded system platform to directly connect with the IoT device. As you can see from here, the micro USB which is being connected is directly connected to a PC, which would be taking in live footage from this camera. So now you understand where we are trying to go with this embedded devices, right? Again, when selecting embedded devices, you have to see the device, what is it's capable of, right? go to the device, right? Check the schematics, check what is possible, what is the processing power, so on and so forth, right? If you have a microcontroller, here you have the microcontroller name, you search the microcontroller, then you will find the processing power and all. So we have the clock speed here, right? And we have what are the voltage, input volts, input operating at 3.3, right? Okay, we have a 5 watt pin here, similar, and we would have also, again, the data sheet would be available, or the schematics will be available. But when we are going back into the project, right, when we are to build a project, now we can see and understand what are these pins are for, right, and how can we use them, right? Then again, my main goal on this lecture is to make you understand what is a embedded system. Embedded system would be the platform that we are using to connect with sensors and actuators. It would have processing power, as you can see. It would have processing power, memory, and also electricity, control of electricity power to the respective devices, either sensors or actuators, right? To and have the ability to, it will be the platform that will be making them work together the way we want. Okay, if we get back to the slide, PPT again, right? So as you can understand that in the marketplace for IoT devices, we can see that there are a lot of products with different parameters again, and to fulfill different functions, right? So we talked about Arduino. We went to the Arduino page and we looked at Arduino Uno and how the data sheet is and what are the pins. We try to recognize the processing unit, the power input, right? Then the power output, analog pins, and the digital pins, right? We try to understand, and this is the connectivity to the PC. So we try to understand what is this board. Looking at this board, we can go to Arduino Nano. This is a smaller version of Arduino Uno, right? With a smaller form factor and fewer pins. So these number of pins are less than Arduino Uno, which means that the amount that it could support could be less. It is commonly used in projects where space is limited. As I told you, we have to select depending on the project. So Arduino Uno is for, right? If you take wearables, for example, if you are going to make a wearable prototype or something like that, you would need very small, you have to have your processing power and everything in a very limited space, right? Even if you have seen your phone, the capability of your phone, and think of the processing power and the electronics that are inside the phone in that small structure, how small and how limited the space would be to build such a thing, right? In phones, we talk about the camera bump. The camera bump is actually there because the space is not enough to keep the entire sensor inside the form factor of the phone itself. That is why we have a camera bump. So things like that, right? So again, Arduino Uno, if the parameters, the size parameters of Arduino Uno is not enough, you can use Arduino Nano. And because we looked at the schematics of this, now we can understand, okay, there are a set of pins, we can look at a data sheet and understand what are those pins and what would those pins do. There are things written on it. We can now read and understand what is it. We can see that there's a processor, there's a reset button, there's a reset button on Arduino Uno as well, and we can also see that there's a, in this it's a micro USB, and we don't see a power input. That means the micro USB will be powering in the Arduino Nano itself. Normally a 5 volts will be the input, similar to powering up, charging a smartphone, right? So here we can see that there is a micro USB, and here is a USB B port which is there to connect to the PC, right? So we are using this embedded system as a platform to connect with sensors and actuators, right? How are we going to use that? So I added this small bit before, like we will learn these steps step by step, right? But each I'm just going to give you an introduction at this particular juncture. Each embedded system has the ability to connect to a PC, right? And for Arduino there is a separate IDE where you can write your programming and upload it directly into your Arduino by connecting it to the PC, right? This will be the interface that you will be using for programming it, right? This will be how you will be connecting it, right? Depending on the connectivity. Right now you have a simple idea. Here you can see that it's been connected, so it is taking in data and taking in data or taking out data, right? We can reset it, we can reprogram it. That is the whole point of it, right? And you can see that the pins are being used to input and output signals, right? So this is a physical visual representation of what you will see in a embedded IoT system, how it would work, right? When you build a project, this is the schematics of how the connectivity will take place, right? You can see the pins are being used, there is power given to the board, but because these are two motors, there is a separate power battery unit which is giving power to the motors, because the Arduino board is not enough. So depending on the project, we have to check those parameters, and either if more power is needed which the Arduino device cannot provide, we have to provide them separately. Things like that, as we go on the project, we have to understand them and do the needful, right here you can see now these are we talked about them. This is the digital side, and digital we have general purpose input output pins here. So input and output will be going here. You can see it's in 1 2 3 4, so 4 inputs we have connected. As you can see right now, you will be able to recognize that these are actuators. So that means so this is a controller which would be there to control the speeds. Again, that means the input, it will be a input, so we will be sending out our data into the maybe to control the speeds of the motors and so on and so forth, switch them on off one at a time, things like that, right? So this will be so you now you have a general understanding of how it would be going. We have an embedded system. Whatever the embedded system, it will be connected to the your PC, and you will have the ability to read and write data into the embedded system. You will be using different coding languages and different depending on depending on the requirement, depending on the platform that you are using actually, right? So depending on the platform that you are using, right, you will be using your uh, uh, coding software, right? But the general idea of it is every platform can be connected to your PC, and you will have the ability to program them whatever the way you use. So for example, when you have one project completed, you can reset. There's the reset button over here. You can see that there's a reset button, right? This is the reset button of Arduino. No, you can reset your Arduino and upload a different code for another project, right? So this is the platform that we are going to use to take in sensor data, take out and output information or commands to the actuator itself, right? Right now what we are doing, as we learned about earlier, we learned about sensors, right? We learned about these sensors, we learned about actuators, we learned about networking. Now we are learning about embedded systems, right? And how we are just taking an introduction to it. While doing the project, we will learn, right, after connecting, what to type, how to type, right, how to program them, and so on and so forth, right? The theoretical parts of it. But as you can see by now, because there's a physical element to it, because there's hardware components to it, you need to practically go through, you need practicals to understand or do a project and get the feeling of how to build IoT devices, right? So if you go, there are other options as well in Arduino. We checked, there were multiple number of boards available. Arduino Mega, this is a large board with more digital input and output pins and more memory. That means it is built to facilitate multiple number of either sensors or actuators. So it has the ability. It is commonly used in projects that require more processing power and more input outputs. So that is, if you have more sensors, if you have more actuators, you need to have more processing power, run more commands, take in more data. So that means the larger processing power plus a larger board with more inputs and outputs. Arduino Duo, this is the Arduino board that is based on more powerful microcontroller and has more memory and processing power. It is commonly used in projects that require more advanced features and performances. Another way to look at it is that if you have demanding sensors which would need more processing power, right? If you have a camera system and that camera system needs to function by itself and do image recognition, things like that, you need more processing power. So that's why more processing power is given to these boards, and so on and so forth. You can see from there are different products which fulfill different criterias. Similar to Arduino, there are other embedded systems. Then the next most famous one is Raspberry Pi. Raspberry Pi is a series of small single board computers developed by the Raspberry Pi Foundation in UK. It is this is a credit card size computer that plugs into a display board and a mouse, and can be used for a variety of projects ranging from learning to code and build internet IoT devices. So this, by the let me go through the statement, and then we will analyze the statement. The Raspberry Pi board are based on different ARM processors, right? So yes, we have, again, like Arduino, we have set of Raspberry Pi boards, right? But okay, we will analyze one by one. The Raspberry Pi board runs on Linux operating system and can be programmed using a variety of programming languages including Python, C, and Java. The boards have GPIO, right, pins that can be used. GPIO pins we talked about in Arduino as well, general purpose input output pins that can be used to interface with various sensors, actuators, and other electronic components to create interactive projects and prototypes. So again, this is like an Arduino board, but there is if you go back to the statement, you will see a difference between Raspberry Pi and Arduino. A series of single board computers developed by Raspberry Pi, and it is credit card sized computer that plugs into a display, keyboard and mouse, which means that this itself is a computer, right? Arduino, we need to connect to the PC. We need to connect to a PC to program it. This in itself has the capability, has the GPU, CPU, RAM, and input output capabilities in a credit card size motherboard to act as a computer. So that means we are going to do our programming using Raspberry Pi itself. That would be the difference. So Raspberry Pi Model 4, Raspberry Pi 4 Model B. This is the latest Raspberry Pi. So we have a ARM processor up to 8 GB of RAM. I think we can get much better ones as well. USB 3 ports, we have USB-C as well, if you see the picture over here, and things like that. So we have the set of pins, right? We have the general purpose or GPIO pins over here, right? We have a processor, we have memory. Let me go to the next slide so we can just check the information, right? We have memory over here, right? We can different boards comes with different specs. So we have a processor, memory, we have the pins, we have USB-C, we have micro, we have 2 micro HDMI ports, right, where you can connect to your screen, USB 2, USB 3, and a gigabit Ethernet connection. So this is it in itself is a credit card size PC. A credit card size PC, right? So you can see here there's a headphone jack also, right? That means basically you can, if you have a USB mouse and a keyboard, you can connect it. Then you have the HDMI ports to connect a small screen, and you can do your coding and everything on this board itself using this as the PC itself, right? And you can connect your sensors over here. As you can see, it's a far greater powerful unit than Arduino. So the application of Raspberry Pi is also a little bit powerful, right? The requirements, if the requirements for the IoT system is intense, and maybe multiple number of sensors needed to be used at the same time, and a multiple number of actuators needed to be used at the same time, and we need to automate everything, we can use something like a Raspberry Pi to build such a system with higher processing power. So these two are the main two that is being used in prototyping IoT devices, Arduino and Raspberry Pi, right? So again, we are only taking introduction to embedded systems, right? In the similar way, right, as we connect actuators and or sensors to Arduino, we can connect actuators and sensors to Raspberry Pi. We have the set of pins. Now we are familiar with what is an embedded system. We are familiar with the pins. The only difference is when you connect this to a HDMI port, when you connect your HDMI port to a screen, you will see a Linux operating system, and that Linux operating system, right, you will open a window and start similarly programming these pins, right? What are the inputs or what are the outputs needed to be done, right? If you okay, so we for Raspberry Pi, right, we similar to Arduino, right? When you are connected into a screen, you will see such a interface, and you will be able to program your IoT device, IoT sensors or actuators only in this IDE, right? And here you can see Raspberry Pi being used to control or taking data from a temperature and humidity sensor, right? Really unnecessary use of the resources right here, because the processing power, this can be completed through Arduino embedded board, because the processing power and the abilities of Raspberry Pi is a lot. And when allocating the processing power and understanding the needs of a IoT project, right, a simple project like this can be completed through Arduino, rather than spending spending money or using in the processing power of such a powerful board, because Raspberry Pi itself can act as a PC itself, right? The board is it has the capability to run Windows 11 in it as well, right? So let's look from that, we will go to another board, right? So another embedded processing device, right? It's the Node MCU, right? Again, another brand, another device. The function of it would be the same, right? Node MCU is an open source firmware and development board that is based on ESP8266 Wi-Fi module. It allows developers to easily build an IoT device and applications that can connect to the internet and interact with cloud services. So you can see that it is the main target of this board is to have the connectivity with the internet and having an inbuilt system to it. And again, I will just put a reminder out there, the new boards of most of the new boards will come with either Wi-Fi, Bluetooth or connectivity. If we don't have those Wi-Fi connectivity or any other protocol we are running, right, we can simply buy a separate board, right? If you are using Zigbee in that particular smart building, we can use a Zigbee board, connect it to your Raspberry Pi, and then the Raspberry Pi will have the ability to connect to the Zigbee network. So that's how it is done, right? So these embedded systems are the platforms that we will use to connect all those networking and peripheral devices together. The Node MCU board is built around the module and includes USB interface, a voltage regulator, and a bunch of pins for interface with various sensors and actuators. The boards can be programmed using in Lua scripting language or the Arduino IDE, making it easy to get started with IoT development. So Arduino IDE is the most commonly used in programming, so we can use the same to program this as well. We can see there's a micro USB, we can see the pins, we can see that there's a processor, we can see that there's a antenna as well for Wi-Fi connectivity on that board. Node MCU boards are popular for wide range of IoT projects, including home automation, sensor monitoring, and smart devices. They can connect to the internet using Wi-Fi and interact with cloud services such as AWS IoT, Google Cloud, and Microsoft Azure. So one of the things that are not there in this syllabus, and one of the things that are there in the IoT sphere or the IoT technology itself is IoT devices connecting to the cloud, right? So this node MCU is directly built to facilitate that, because if you have a sensor which is let's say if you are in a factory and you need to have the let's say the temperature of that factory building at every location, right? The building could be a vast place, right? Factory buildings are normally larger in size and you need real-time readings of the temperature. You can use such this node MCU device, right, with the sensor, right? We talked about a sensor like this, temperature and humidity, right, and feed that into a Wi-Fi network which will cover the entire factory floor, right? So that and that data can be directly uploaded into a cloud rather than an internal server or something like that, so that anybody who's have the ability to access that data or have the permission to access that data can access it from any location around the world. So for multinational companies who would need to monitor manufacturing capabilities in different countries can create IoT devices to fulfill these requirements. So we talked about Raspberry Pi interface as well. This would be then similarly it would be connected to the PC and will use this IED to program. Right now you have a basic understanding and handle of what is an embedded system, what are the features in an embedded system, how can we connect the embedded system, how can we program the embedded system, how we connect our embedded system to IoT devices, right? How the pins are being used, how it is used to program, and those things. Now you have a general understanding. You have an understanding of it has the processing ability, the RAM or the GPU which is needed to be in Raspberry Pi's case, the GPU which is needed to carry out its functions. Other embedded units or other embedded systems that are there in the market. Similar to sensors, there are a lot of embedded systems, right? Adafruit has, the brand itself has a wide range of embedded systems, right? Adafruit is the one that creates Raspberry Pi, I think also as well, but they have a set of different boards with different parameters or specs. Then separately NRF52840 board, right? For that is, these are not commonly used. Beaglebone Green Gateway is one of the other ones, which is similar to, which has the processing power, right, more than Arduino. But then again, in I don't think, yes, this doesn't work. This only this works like Arduino itself, right? Again, the connectivity to a PC, we can program it the way we want. So we can see in each device there are a set of pins which facilitates the input and output, right? Each pin is named, as you can see over here, the names are there, right? And there are data sheets, so we can use any board the way we want. STM 32MP, okay, it's the discovery kit. The discovery kit itself is similar to Raspberry Pi, right? You can see that it has, again, it has a set of pins to facilitate the IoT sensors, actuators, network boards if necessary, right? And we can see that there are multiple USB ports available. We can see that Ethernet connection is available, and a HDMI port is available. So that means this will be going on, this would be going on the same path of Raspberry Pi. These ST products are also famous for IoT devices, but I mainly described these two, Arduino and Raspberry Pi. These are the commonly used ones when coming into embedded systems, right? So one way to look at these embedded systems is that this is the platform that we use to control our sensors and actuators. When we are prototyping, when we are building an embedded IoT device, which is our end goal of this, which will be our end goal of this lesson, or of this subject, right? We will be using this embedded system as a platform to connect our actuators and sensors and take readings out of them, right? So these are the embedded systems examples, right? And here we are, right, end of our program, we will be looking at building an embedded system or an embedded IoT device, right? That would be our end goal. So multiple devices connected together will create an embedded system. That system can be connected to the network, to the cloud, and to applications as well, right? So we are actually looking at Internet of Things, right? Internet, we are going to look at mainly about the things that are making Internet of Things. Here again you can see we have a IoT project using Raspberry Pi. We can see it's a Raspberry Pi motion detector with photo capture. What does that mean? So that means this IoT device, when motion is detected, it will take a photo. This sense is a motion sensor. We talked about it before, right? This is an example I'm just giving to understand how these are connected together, right? How all these embedded systems are connected with sensors and actuators, right? This is another example how to show you visually how these are connected, right? You have a motion sensor. Those motion sensors will be feeding in data to the Raspberry Pi. From that, right, when the values are given, right, under the parameters, right, we have to write the program here, right? When the motion is detected, right, then a signal will be sent to the camera to capture a photo. So that would be the IoT device, that would be the project. So that this is a prototype of a device, right? When we build a casing, when we have a, right, when we have beautifully built it, it would be those IoT devices that we see on the market. But the initial prototyping will take place, the feasibility of prototyping will take place is in a similar fashion. These are the specs of Raspberry Pi. We have gone through it, right? We now understand, similar to sensors, actuators, right? We, similar to them, embedded systems have their processing capabilities, have their performances, have their sizes as well, right? Something that we know is Raspberry Pi is a credit card size PC. Arduino is also similar size, but Arduino Nano is separately there to facilitate it if we need to make smaller prototyping, so on and so forth, right? So now, as we have covered the sensors, as we have covered the embedded systems, as we have covered the networking, all those layers, so the components of an embedded IoT system, now slowly by slowly we can move to build, right? Slowly by slowly we can move to build a IoT embedded device. Before ending this lecture, right, I would like to show you that, okay, when we have embedded systems, Raspberry Pi, Arduino, right, of course, how these are the schematics of the connection of the same sensor to the two different embedded systems. Gas sensor with Arduino sensor MQ2, right, how this is being connected, and the gas sensor MQ2 same to Raspberry Pi, but here it goes through a microcontroller, right? So it will control the convert the analog signal into a digital one, because this takes in digital. They only have digital pins as well, but we know that we learned about there are analog pins in Arduino, so it can directly take in data, but here there should be a separate processing there is separate processing taking place, because Raspberry Pi takes in only digital data. Then yes, so this is another example. So we talked about sensors, so this is an example on Arduino actuator project. So 4-channel relay and power supply. So that means this example is there mainly to show that we talked about Arduino having the capability of giving a 5-volt output, but when coming into some devices, we talked about earlier examples as well, the power is not sufficient enough. In that particular point, we should have relays, right, and external power sources, either through batteries or from direct power, connected, so that we can have the actuators giving the output that we want. So one of the things that we should remember is these embedded systems, right? These embedded systems would need though it has the ability to process the commands and process data, sometimes external power sources are needed to uh, to get a final result from the IoT device or the IoT prototype we are going to make. That is one of the points. And the other point is, if we need them to be connected into a particular network, particular IoT protocol, Wi-Fi, Zigbee or Z-Wave, which are commonly used, we would need these embedded systems to be connected with these network boards as well, because then they will facilitate communications. They will be similarly connected in similar to sensors and actuators. They will be connected in the similar way, right? And we should follow we should then do the coding part to integrate those network boards into it. So in this lesson, top to bottom, what in this lecture what we got is introduction to sensors, introduction to actuators, introduction to network, and introduction to embedded systems, right? Again, now we know what are sensors. Now we know that there are pins, and they will, why these pins are there, right? Why these wires are there. We know that there are different kinds of sensors with different parameters. Sorry, there are similar kinds of sensors, right? Similar sensors with different parameters and different products, right? We have temperature sensors, which are different brands make them with different parameters. So depending on the requirement of our project, we have to select the correct sensor, right? So we learned about different kinds of sensors that are there on the market for different to sensor different environmental factors, right? And we learned that there are multiple number of brands which gives each sensor category with different parameters, and we need to select the correct one. Then we learned about actuators, right? We learned about motors, solenoid valves, relays, right? We learned about them and how there are different products as well in the market. Depending on our requirement, we should again select the correct one. Servos, LEDs, speakers, displays, right? We all know that even if you take displays, right, the example is a simple display. There could be black and white displays, there would be color displays, there would be touch sensitive displays, so on and so forth, right? We learned about other actuators as well, right, as examples. Then we talked about the network layer, right? And we learned about we took an introduction to things like Z-Wave and Zigbee, which are dedicated protocols, which are dedicated IoT protocols for networking. Then we learned about embedded systems, which has the capabilities of processing, and which we will use these embedded systems as a platform for connecting our sensors, actuators, and networks together. We took a small introduction of what are the embedded systems that are there in the market. We learned how we are going to program them. Not learned, we took a small introduction, peek into it, right? Now we have a general understanding of, when building a IoT project, what are the components that we need, right? We talked about, we now know that, okay, whatever the embedded system, we can connect the sensor to the embedded system, but we should know what are the requirements that are there, right? The compatibility of it is, we need to check. So before ending this lecture, before going forward, if you are to make your life easier, I would like to give a advice from my days of learning, when I was learning IoT devices and so on and so forth. So when you have a IoT project, or when you have a IoT requirement, the main point that you should first see, if you are going to build IoT device, right, is what is the sensor you need, right, and what is the actuator you need to build your project. Let's say you're going to build a simple project, you're going to use a sound sensor, and when you select your, right, so when you have a sound sensor, you will see the requirements that you need to detect what kinds of sounds and so on and so forth. Then when you select that sensor, make sure that that data is available, information is available from the internet, all the information is there, right, for you to use that sensor with the correct embedded device. Is it easier to use it with Arduino? Is it easier to use with Raspberry Pi? Does it have the capability? What are the things that you need to change? For example, here, the best example here is, right, if you have the MQ2, right, it is easier to use with Arduino because there is analog inputs. If you are using Raspberry Pi, you should have the ability to use a separate microcontroller, right? Should know what is the microcontroller that you should use, because you have to convert that analog signal into a digital signal. So the compatibility issues when prototyping, right, before building your device, before collecting your hardware equipment, it is better you have an understanding or do the needed research for compatibility. It would be easier, you will be facing less errors when doing so. Arduino has its own supporting structure, right? Arduino, you may have seen Arduino kits, and those kits are there mainly which are 100% compatible with the Arduino boards, so it is easier to work with, right? Of course, that luxury is not there when you are going to build your custom IoT device, so you have to make sure that the compatibility is there. So we will for today stop the lecture from this point, right? Now we have a general understanding of sensors, actuators, networks, and embedded systems, the four main components which we need to build a IoT embedded device. In the next lesson, we will be taking a small deep dive. So we will be looking at our exam. In the next lesson, we will be looking at the examples we checked before, right? In our first lesson, we talked about a robot arm, we talked about a Roomba, we talked about smart smoke detectors, right? We talked about smart thermostats and how these are connected. So what we are going to learn in the next lesson is what are the sensors, or what are the set of sensors that are being used to create a IoT device. What are the set of actuators and sensors which are used to build a IoT device, right? So then you will understand, okay, these sensors are working with these actuators together, right, with processing capabilities of maybe a custom design board, but anyway the processing abilities and how these IoT devices are made. So in the next lesson we will be looking at that perspective. We will look at those examples we looked at IoT devices before, and what are the sensors that are used on those IoT sensors and actuators which are used on those IoT devices, right? After understanding that, we can then move to build our own IoT device. So there is time, so little by little we will move forward, right? For now I think we have covered enough. Right now we have understanding of what are the components of IoT. Right, next in the next lesson we will see how these components work together to build a IoT device. So what are the components need to build a specific IoT device. Okay everyone, we will be ending the lecture number 5 here. So have a great day. See you in the next lecture.